Okay, we've been talking about trig functions for a little bit. Sine, cosine, tangent, cosecant, secant, and cotangent. We're going to still talk about those, but instead of doing like y over r and x over r, we're just going to do what we've always known. So sine of theta is opposite over hypotenuse. You already know that. Next, cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent, so SOHCAHTOA there. And then we know that everything next to those are the reciprocals of them. So what was next to this is cosecant, and that's the opposite of that, the reciprocal of it, so HO. Secant theta is HA, and cotangent theta is A over O. Okay, so those are the ratios for those. What I would do, and what I've done, I believe, on mine, is I've copy and pasted that, because we're going to have to answer about those 6 trig functions on a few of these questions. So I actually have it, I think I have it copied. Yeah, I've got it copy and pasted like this. You might want to do the same, just so you can do that on each one of these problems. Okay? So the first one, find the values of sine, cosine, and tangent. So we don't need to know all 6 for this, but we could figure out each. Okay? What are we all laughing about that sound? Did you set it off again? I don't know where it is.
Like 5 seconds.
I don't know. I really wish we would continue this weekend.
Okay.
Yeah, that's kind of dumb. I'll bring in my kitchen timer.
Okay. So remember, this is the angle we're looking from. So we're looking from theta, and we're trying to find sine. Sine is opposite over hypotenuse. So the opposite of this is 24 over the hypotenuse, which is 25. If you don't remember, the hypotenuse is the longest side. It's also the side that this square points towards if you make it an arrow. Okay, cosine of theta, that is the adjacent side, so the side next to theta, 7, and the hypotenuse is 25. And then tangent is opposite over adjacent, so the opposite is 24 over the adjacent, which is 7. Okay, that's stuff you learned in 9th grade. I think you've touched on it since then as well, so it should be stuff that's pretty straightforward. So let's move on to the next one. So let's find the value of the 6 trig functions. So we're going to have to find all 6 this time. But in order to find all 6, we need all 3 of these sides. So you have to do the Pythagorean theorem to figure out this third side. So 6 squared plus b squared equals 12 squared. Okay, again, you know how to do that, so we're just going to skip to what b is. B ended up being 6 root 3. So this side is 6 root 3. Okay, and then from theta, this time theta is up in the top, so just be careful of that. A lot of people assume it's here. So this is the adjacent, this is the hypotenuse. So then our sine is going to be 6 root 3 over 12, and that can be simplified. So our outside numbers can work with each other. So that's going to simplify to root 3 over 2. Our next one is the adjacent, which is 6 over the hypotenuse, which is 12, so that's 1/2. Okay, tangent is 6 root 3 over 6. The 6's cancel, so our answer is just root 3. The other side is just the reciprocal of that. It's easiest to flip this, not this. So I would put this, not that, or just do it on the page. So sine is O over H, so this is H over O. So 12 over opposite. The opposite is 6 root 3, so 6 root 3. We can simplify that first, so that is 2 over root 3. But then we also have to rationalize. So rationalize that to 2 root 3 over 3. And then let's finish that out. So 12 over 6 is 2. And cotangent is 6 over 6 root 3, which is 1 over root 3. Okay, you can see that every one of those is the reciprocal, even this one. If we flipped it and then rationalized, it would end up being that anyway. Oh yeah, we got to rationalize that. I don't know why I didn't do that on my notes. Good call. Okay, so let's rationalize that. So that's root 3 over 3. Yeah. Okay, so those are all reciprocals. That's how we should do that. The main one, again, on that is that actually a lot of people last year, for some reason, immediately thought this was where theta is. So you have to actually go from a point of reference, and they label that point of reference for you. Okay? Next is this word cofunctions. This is also something that people had a hard time understanding, and I had a hard time understanding why they had that. The cofunction is a complementary angle with the function with the co of it. Okay? That was said really weird. But what it means is if there's co at the beginning of it, take it off. If there's not co at the beginning of it, add it on. So the cofunction of this means you're going to take co and add it on if it's not there. So there's tangent. So we're going to add co to the front, and that's now cotangent. And then we're going to do the complementary angle of that. So what's the complement of 23? What's complementary mean? Adds to what? It's 67, because it adds up to 90, right? Complement means equals 90 degrees. So 67.
Watch the swivel just for that quote you said earlier.
I know, that was really bad. Okay, but basically all it means is if there's not co on the word, add co to it. That's how we get cotangent. If there's co on the word, take co away. So the cofunction of cosine is just going to be sine, because we took co off. That's what I was trying to say. And then we do the complement of it. That's one of the things where I remember a lot of people missed. They just couldn't wrap their head around that. Okay? So cofunction does not mean the reciprocal function. It does not mean the I don't know where I'm going with that. Okay? But the cofunctions are arranged like this. Those two are cofunctions, these two are cofunctions, and those two are cofunctions. Because they're basically the same word with co on one of them. Sine, cosine. Tangent, cotangent. Secant, cosecant. Okay, those are the cofunctions. Next, special triangles. These special triangles actually come from the unit circle as well, which we'll talk about more next class, or next chapter, not next class. But here are the special triangles. We got a 30, 60, 90, and we have a 45, 45, 90. The reason these are special is because we can use their proportions to figure out other stuff. Okay? So these are ones that you do have to have in your head. This 30, 60, 90 is going to have a 1, a 2, and a 3 on it. Okay? And it's going to be opposite of its corresponding angle. So of these 30, 60, 90, what's the smallest angle? 30. So the smallest number of 1, 2, and 3 is going to be opposite of that. So 1. Okay? 2 is going to be our hypotenuse because that is the biggest number of those three numbers because the 3 has a root over it. So that's actually 1, 1.7-ish, and 2. So it's always opposite of its sized angle. So the smallest angle goes here, the largest angle goes to the largest number. Okay, that's the first one you need to have memorized. And then the second one is the 45, 45, 90. That has a 1, and if the opposite of 45 is 1 here, the opposite of 45 is also going to be 1 there. Because this side length has to correspond with that angle. So that means that if this is the same angle, that side length has to correspond. And then the hypotenuse is the root 2. Okay, those are two things that you do have to have memorized in order to do this section. They do start coming naturally if you write them down each problem. Okay, so let's look how that affects our problems. So this says find the exact value of the cosecant of 45. So we have a triangle that uses the degree of 45. So I'm going to write that down. Here's our triangle. Okay, there's our triangle. That's 45, 45, and 90. It says what's the exact value of the cosecant of 45? So we know that 45 is 1, 1, root 2. Okay, so we know we're looking from this angle, so we can pick either one of those 45s. And then cosecant. What is cosecant? Cosecant is H over O. Because it's the reciprocal of sine. So from this reference angle, from this angle, you're going to do your hypotenuse on top of your opposite. So then your answer for that is just root 2. So I'm going to write the degree in there for you. Okay, so if it asks you for the exact value, because I know that you can take your calculator and type this in, that's going to give you a decimal. It wants the exact value. It doesn't want anything rounded. So you have to use your triangle in order to do that. We know another triangle that uses 60 degrees, so we're going to write that one down. That's our 30, 60, 90 triangle. So this is 30, 60, 90. So opposite of 30 is 1. Opposite of 60 is root 3. And opposite of 90 is 2. Okay, so 60 is our reference angle. So we need to figure out what tangent is first. We know tangent of theta is our O over A, our opposite over adjacent. If 60 is our reference, we're going to start here, and we're going to do our opposite over our adjacent. So tangent of 60 degrees is the root 3 over 1, which is just root 3. Any questions on those two? Those are basically the basic ones of that. We understand that? As long as you know that triangle, then it's just SOHCAHTOA. Okay? But you have to know those triangles. Alright, so this is a different way they could ask that same thing. Find the equation of the line passing through the point 0, 3 and making a 30-degree angle with the line y equals 3. They have that for you right there. It's making a 30-degree angle. So here's a 30-degree angle. That means that this can make a 30, 60, 90 triangle. Okay? So that's the triangle we're going to use. So that's a 30, that's a 60, and that's our 90. We can also put our labels on it. So the opposite of 30 is going to be a 1, the opposite of 60 is going to be a root 3, and the opposite of 90 is going to be a 2. Okay? Next thing it says is to write the equation of a line. Our equation of a line is normally, the easiest way it is written is y equals mx plus b. So what is b in this, on this graph? Where does it cross the y-axis? What is the b of the green line? Is it 3? Yeah, it's 3. Okay, so b is 3, so plus 3. And it also says that right here in the problem. So you don't even need the graph to see that. Okay, so now we need to figure out our slope. Our slope is rise over run. So our rise is 1 and our run is root 3. And then we want to rationalize that. So y equals root 3 over 3x plus 3. Okay, that is a very popular problem. So you will see that one over and over again. Okay? Again, all you have to do is know your triangle. Once you know your triangle, that's just rise over run. That's something you learned, again, freshman year, once you have that triangle written on the graph. Okay? You could also do it by actually counting, finding your points and finding the slope of that line. But it's pretty easy to do it once you have that triangle in your head. Okay, we're still going to use those triangles or stuff associated to them, but we're going to do something now called reference angles. Reference angles are the positive acute angle associated with every non-quadrantal angle made by the terminal side and the x-axis. Okay, what that means is if we have any non-quadrantal angle, so anything that's not on the axis. So I'll just pick this one. Okay? It's the positive angle, so positive acute angle associated with the x-axis. So whatever angle we can make with the x-axis here. So this one. Okay? That's how you would find it. It's however you can connect to the x-axis positively. Okay? You're going in the positive direction. So that's how we're going to solve these. 218. We do not have a triangle that says 218 on it. We don't have a unit circle that has 218 on it. So we need to find an angle that references that we do have a triangle for. So 218 would be about, if you remember, we talked about how the line starts here every time, and 218 will be about right here. Okay? We need to find the reference angle of that. The reference angle is how to connect that to the x-axis. So we can connect that to the x-axis going this direction. So what is this degree right there? Anybody think they know? What is the degree of this reference angle? Because what's this line at? 180. And now we're going to 218. So what degree is between those? 38. So all we did there is we took 218 and we subtracted our x-axis. 38. Okay? In this case, that 38 is also not on our unit circle or on our triangles. So we couldn't really do much with that right now. Okay? But later we will. So on these, it will end up working out for us. So what about this big one? That's not on a circle in general. We have to get it down below 360. That's why we talked about last class coterminal angles. So we need to subtract 360 a bunch of times and see what that actually ends up equaling. So subtract 360 for me. Somebody get it to the least positive coterminal angle like you did on your homework that we do today. Minus 360, like, I don't know, 3 times? Try 3 times. Anybody got a calculator? I do not. Does that work? Minus 3? Is it 307?
307.
307? Okay, so 307, that is on our circle, so we can put that onto the graph now. We start here. This one would be 180. No, this would be 90, 180, 270, so 307 would be over here somewhere. Okay, we want it positive. That means we want it starting here and going positive this way. We do not want to go this way down. We want to go all the way around. Okay, so what is this? That's 307. And then we want to keep going positive in that same direction. So we want to go this way. And tell me what that angle would be. What would be left over here if we just use 307?
53.
53. So that's our reference angle there. Okay? So we do not want to go back to the 180 side. We want to go to the closest positive. So we want to go here. We do not use that. Okay, so now that you know that, it's going to make it an easier angle to deal with. Using reference angles, we want to find all 6 trig functions for this. So we're going to want this again. But we have to make our own graph over here. Okay, so here is a graph. 210. 210 is a little bit past 180. So here's the start. It's about right there. It's a little bit past 180. How much past is it? 30 degrees. Okay, so our reference angle is 30 degrees. We know of a triangle that uses 30 degrees, so we can use that triangle in order to solve these. So right below it, I'm going to write that 30-degree triangle, and I'm going to try and make it look like this graph. So like this. There's my 30. There's my 90. And there's my 60. So that's 1, root 3, and 2. Okay, the only difference between this and what we did before is that this is actually on a graph, which means that this is actually directional. So that is going in the negative direction, and this is going in the negative direction. So make that a negative and that a negative. Because those are actually directional right now. Okay, our reference angle is 30, so from 30, we're going to answer those 6 questions. So from 30, we need to find sine. Sine is opposite over hypotenuse, so the opposite is 1 over the negative 1 over 2. So there's your answer for that. And from there, we just use that reference over and over again. So cosine is adjacent over hypotenuse, so that's negative root 3 over 2. Tangent is opposite over adjacent, so the opposite is negative 1 over the adjacent 3. So those become positives, and then we rationalize. So root 3 over 3. and then do the reciprocals on the other side. So do that other side. So this whole section is devoted to those triangles, basically. Okay, I've got the reciprocals written up on the board. That's why we always want to try and write them in that order, because the reciprocals are always next to it, so it makes it easier. Another way you can view this, if you remember what you did last class when we had to figure out which of these were positive and which of these were negative with all those drop downs. What letter is associated with sine, x or y?
Y.
Y. Remember sine y? Cosine's x. Okay? And then this is just your slope. This is your y over x. Okay? So another way to know that, instead of memorizing that table with all the pluses and the minuses on it, is you just think about your graph. In quadrant 1, everything's positive. Your x is positive and your y is positive. Okay? In quadrant 2, you're going to go in the negative direction of the x, but your y is positive. In quadrant 3, everything is negative. And in quadrant 4, positive and negative. So I just wanted to throw that in there, that you can also use a graph to decipher that. So something's wrong here. Oh no, it's not. There's a negative. Okay? So why are these positive? Because this is the ratio of these. So if I have a negative over a negative, that ends up being a positive there. Okay, so you can also use that. Again, that's just starting to tie it into the unit circle. So that's not something you need to know. I'm just trying to have something to refer back to when we talk about it. Okay, last one. Using reference angles. Find just the cosecant, so not all 6 of them. It says using reference angles, that means we need to figure out what our reference angle of this is. First, we need to get it to less than 360, so we can figure out where on the graph it would be. So where on the graph would 870 be? What is a coterminal angle of 870? Is it 210 again? Yes, it is. Okay, so 210 here again. So if this whole thing's 210, we only need our reference angle, so we go from the x-axis. So our reference angle is going to be 30, because 210 minus 180. And then we can use our exact same triangle as above. Do I need to explain the coterminal again? Are you good? Okay. Yeah, so it's just like on last night's homework. You just add 360 until you get it to positives. Okay? So then we can use that exact same triangle because our reference angle ended up being 30. If our reference angle ended up being 60, we use the same triangle, but we turn it a little bit. If it was 45, we'd have to use the 1 root 2. Then we want to find cosecant. Cosecant, we know, is h over o. So we know that cosecant of, not theta, cosecant of negative 870 is 2 over negative 1, which ends up being just a negative 2. Because cosecant is hypotenuse over opposite. So from this reference angle, hypotenuse over opposite, and then we simplify it. Okay, so the reason why I start losing people on this lesson is because it does start really getting into more unit circle stuff. Again, these triangles come from the unit circle. So if you look at these triangles that you have to memorize, every one of these numbers is part of your unit circle. And every one of these degrees is part of unit circle too. So,
Can you go back to the last one?
Okay. Again, you won't have to have the unit circle memorized until next chapter. I will hand you a piece of paper with it on it so you can look at it. But just start realizing that these numbers are ones we're going to see a lot, because those are the ones that are uniformed on that unit circle for you. Okay? Can I move on from that?
Yeah.
Okay. There was one thing that I thought of at the beginning. This one. If you look at this, I think this is a 30, 60, 90 triangle. And you know that because it's got the same dimensions as our 30, 60, 90s. We have 1, root 3, 2. Right? 6 times 1, 6 times root 3, 6 times 2.
Wow.
So that is one of those 30, 60, 90 triangles. And so you can use that instead of using Pythagorean theorem. You can already know that that's just going to be your small side times root 3. Okay, so that's just another thing you can reference on that.